Hello, Ali. Good evening.
Good evening, ma'am.
Okay, so let's wait for 1 to 2 minutes more, then we will start the session. Okay, so I was waiting for like 8 minutes maybe already. So we have to start today the methods of preparation of alcohols. Five different methods we will see. So let's 1 to 2 minutes more. Let's wait for them, then we will start. And before that, if you have any doubt from the previous session or any question you have any query, any doubt, you can ask me. Any doubt, Ali?
No, ma'am.
Okay, so I think they will not join the session. So let's just start the session. So methods of preparation of alcohols, right? So first method is from alkenes. We can prepare alcohols by alkenes by two processes. So in your syllabus, there are more processes, but in your syllabus there are two mentioned: acid catalyzed hydration and by hydroboration oxidation. Okay. So let's first see first reaction. Let's see that. By acid catalyzed hydration. So what does this mean? Acid catalyzed hydration. So hydration in the presence of a acid as a catalyst. Okay, so in this method, alkenes react with water. Okay, first alkene का hydration होता है in the presence of acid. Okay, and they just form the alcohol. So suppose in this acid hydration and this alkene, so there are two processes. If suppose if they just give you the symmetrical alkene, and what about if they just give you the unsymmetrical type of alkene? Okay, so symmetrical alkene agar hai to you don't have to worry about that. So this is hydration H2O. Suppose acid hydration हम करा रहे in the presence of a catalyst, right? Acid catalyst. You can use HCl, H2SO4, any catalyst. So symmetrical, if it is a symmetrical alkene, just like a CH2 double bond CH2, ethene आप ले रहे हो, ethene. Okay, when you do the hydration of ethene, so what happens? The hydration basically, so you have to, this H2O, it will give you H plus and OH minus ion, right? H plus and OH minus ion. And if it is a symmetrical type of alkene, so you don't have to worry about that. You can attach OH to any of the carbon and hydrogen to the other carbon. So what you are supposed to do, see, so H2O will give you H plus and OH minus ion. So you can attach OH to one carbon and hydrogen to other carbon. Okay, hydrogen to other carbon, and this pi bond will break. So basically, you have to break the pi bond and attach OH to one carbon and the hydrogen to other carbon. So you will get, so what you will get? So you will get carbon. Okay, this is H2. Just a second. So this is CH2. Okay, and here you can attach OH, and this is your CH3. Okay, so basically you will get CH3, CH2, OH. So in the symmetrical, by symmetrical alkene, how you can achieve the alcohol? So by a acid hydration. Okay, acid catalyzed hydration, you can get the ethene. Okay, your alkene can be converted into a ethanol in this case. So the reaction is very simple. But what about if the reactant is unsymmetrical type of alkene? So if it is unsymmetrical type of alkene, just like that, here you can write down, add one thing over here. So what you're supposed to do, this carbon and carbon bond. Okay, basically this pi bond आपको break करना है. Okay, and the new bond will be formed between the carbon and hydrogen. The new bond between carbon, this carbon and hydrogen, new bond will be formed, and carbon and OH. These two bonds will be formed. Okay. Okay. Now, what about if it is unsymmetrical type of alkene? So when alkene, unsymmetrical type of alkene is treated with water. Okay, when you do the hydration of unsymmetrical type of alkene in the presence of any acid, so it undergoes basically a addition reaction. Okay, and here the alcohol will be formed, but you have to follow the Markovnikov rule, Markovnikov addition rule. So because you can see this is unsymmetrical type of alkene, CH and CH2. This is alkene, right? And this is an unsymmetrical type of alkene. So what you are supposed to do, you have to follow the Markovnikov addition rule. Now, Ali, tell me, what is Markovnikov addition rule?
The nucleophile attaches to the hydrogen atom which contains less number of ions.
Okay, I didn't get it. Just tell me if H plus and OH minus. So you know very well this is the OH is nucleophile over here. So nucleophile will attach to which carbon? This carbon or this carbon? Suppose this is a A and this is your B carbon. So to which OH will be attached according to the Markovnikov addition?
A carbon.
Yes. Okay, so basically the nucleophile or OH group will be attached to that carbon which has lesser number of hydrogen. right? So you can see between these two carbon, this has two hydrogen and this has one hydrogen, which will get attached to this carbon, right? And what will be the product? You will get this product, CH3. Okay, this is your CH, and here OH will be attached, and to the other carbon you have to attach the hydrogen, and this pi bond you have to break. Carbon carbon double bond break ho jayega, and you will get this CH3, CH, OH, and this is again CH3. Clear? Okay. Okay, so here you can write on this point. When alkenes are treated with water in the presence of an acid, suppose H2SO4, so they undergo addition reaction and they form alcohol according to the Markovnikov rule. Okay, what is Markovnikov rule? You can write down in your bracket. OH group attaches on that carbon which has lesser number of hydrogen. Okay, and the hydrogen will attach to the other carbon which has more number of hydrogen. Okay, now, okay, let's do these questions. So first one, okay, I will do it two questions for you, and you the remaining one you will do it for me. So this is a symmetrical, this is again an unsymmetrical type of carbon, right? This is your alkene. Suppose if it is your A and this is your B, right? So you can check to A carbon, how many hydrogens are there? How many hydrogen? So two bond is there, so two hydrogens, right? Here two hydrogen is present, and what about this one? This has only one, two, three bonds, so only one hydrogen is present. So where you will attach the OH? OH group should attach to which carbon? B or A?
B.
Yes. Write down. So this will give you OH will be there. Okay, and this will get one hydrogen. So it was first CH2 tha, and now it becomes CH3. So that is your product. That is your product. Okay. Now third one, second one. So you have to check between these two. Okay, suppose this is your first and this is your second. So on the first position, you 1, 2, 3, 4, there is no hydrogen, zero hydrogen. And on the second carbon, there is only one hydrogen. So where you will attach the hydrogen? Where there is no hydrogen, okay, where there is less hydrogen or there is no hydrogen. So you have to attach OH to that carbon, first carbon, you have to attach. Okay, the double bond will break and this CH3 as it is, and you will attach OH to the first position. Why? Because there is no hydrogen, zero hydrogen, right? So you will get this product. Okay, now do the remaining one, third, fourth, fifth, sixth, seventh. Just quickly do that and please let me know the answer. Yes, done. Okay, what about the third one? Suppose this is your A position, B position. So where you will attach the OH?
B position.
Get this product. Okay, the fourth one. Suppose this is your first and this is your second position. So where you will attach?
First position.
First position, yes. We will attach here OH and this will become CH3. Okay, on the second position, hydrogen will get attached and it will become CH3. Okay, fifth one. Suppose this is your first, second.
Second.
Okay, second has no hydrogen, so you will attach. Just like that, you can write. And what about the sixth one?
First.
Okay, first. Okay, seventh one, because seventh is the symmetrical, so you can attach OH to any of the carbon. Attaching on the first one. So you will get this. Okay, so it's clear. Catalytic hydrogenation. Yeah.
No.
Second is your hydroboration oxidation. Hydroboration. So what is hydroboration oxidation? Again, this is the reaction of alkene. Okay, the reactant is alkene. So what happens? This is again a two-step mechanism, two-step reaction. First step में क्या होता है? The addition of borane followed by oxidation is known as hydroboration oxidation. What is hydroboration oxidation? So the addition of borane to the alkene, okay, followed by the oxidation is known as hydroboration oxidation reaction. Okay, see the reaction. Suppose we just take the unsymmetrical type of alkene. Okay, CH3, CH2, and CH2. And in the first step, we will use B2S6. Okay, आप B2S6 use कर सकते हो, or you can also use BH3. Simplified करोगे आप 2 and इसका ratio लोगे, so you will get BH3. So you can also write on BH3. Yes, in some reaction in some books, you will notice that in case instead of B2S6, it's written BH3. So both are same, both are uh, correct, right? So if you use B2S6, okay, the diborane, and in the presence of THF. Now the question is, what is THF? Do you know what is THF? Tetrahydrofuran. What is THF? THF is tetrahydrofuran. This is structure. Okay, this structure is known as tetrahydrofuran. Basically, it is a Lewis base. It is a Lewis base and it acts as a solvent and forms a complex with Lewis acid. So that's why we use here. So it just act as a base. Okay, solvent की तरह act कर रहा है. This is just act as a solvent over here. So that's why we are using here this THF. THF is your tetrahydrofuran. So in the first step, when you use diborane and tetrahydrofuran, so you will get a first आप पहले general reaction लिख लेते हैं. So when you use B2S6 or THF in the first step and the second step, basically you just do the oxidation in the presence of a hydrogen peroxide and NaOH in the basic medium. Hydrogen peroxide in the basic medium. So you will get a alcohol. So it will get converted, your alkene will get converted into a alcohol. Okay, in the presence of P2S6, okay, THF in the first step followed by a oxidation and oxidation in the presence of a H2O2, hydrogen peroxide in basic medium, NaOH. So this is the overall reaction. Okay, now let's understand the mechanism of this reaction. How you just get the alcohol and how the ethene, okay, or alkene over here is converted to a corresponding alcohol. Okay, so let's see or let's understand the mechanism. Suppose you just take the three moles of, okay, 3 moles of CH3 CH2, okay, alkene. Okay, propene हम लेते हैं, 3 moles of propene. And first step, okay, we just do the first step, we just use the diborane, and you can also write BH3 borane भी आप ले सकते हो. Okay, so when you use the borane, okay, so firstly basically it is the process, first step is known as hydroboration. Okay, addition of borane, addition of boron. Okay, so what happens, this BH3, you are just taking the 3 moles of your propane. So what happens? This double bond will, this alkene will get converted into a alkene. Okay, this double bond will break and you will get a 3 moles of CH3, CH2 and CH2 whole thrice. You will get 3 moles of this structure. Okay, alkane में ये convert हो जाएगा, and here the addition of boron will be there. Addition boron will be get attached to this structure, this alkene. Okay, this is the first step. First step is the addition of boron. This is known as hydroboration. The alkene gets converted into a alkene structure. Okay, addition product of alkene. So trialkyl borane. You can, what is this? This is your trialkyl alkyl borane. Trialkyl borane. So in this case, it is tripropyl borane. So this alkene, okay, propene reacts with diborane or borane, okay, in the presence of your THF, okay, tetrahydrofuran. It gets converted into a trialkyl borane because you were using the 3 moles of this propene. So 3 moles आप use करते हो in the presence of a BH3, okay, diborane के साथ react कराते हो आप, so you will get a trialkyl borane. So first step is clear, Ali? See, so when you get the trialkyl borane, so after that, when you do the further oxidation, so what happens in the presence of H2O2, hydrogen peroxide? So what happens? This bond will be break. This trialkyl borane will get converted into a 3 moles of alcohol. Corresponding alcohol means the number of carbon should be same. Only क्या होगा? The OH will get attached to this structure. The OH will get attached to this trialkyl boron. Borane will get removed. Okay, borane will get removed and it will make BOH whole thrice, and you will get 3 moles of your propanol. Okay, so first step, see the first step, 3 moles of propene. Okay, when you treat it with diborane or borane, so it will give you a trialkyl borane, the addition product of the borane. Okay, boron. And on the further oxidation, okay, this addition product is get oxidized to alcohol by hydrogen peroxide in the presence of aqueous sodium hydroxide. Okay, so in the presence of aqueous sodium hydroxide, it will get converted into a corresponding alcohol. Okay, just keep this in your mind. The number of carbon should be same. Only you have to just attach the hydrogen OH group. Okay, and this propane will get converted into a corresponding alcohol by using 2 steps. Further hydroboration कराओगे, addition of boron, and the second step is the oxidation. So that's why this reaction is known as hydroboration oxidation reaction. Clear? Okay. So in this reaction, propene, you can write down, in this reaction, propene reacts with diborane or borane to form trialkyl borane as an addition product. And second step will be this reaction, this addition product is get oxidized to alcohol by hydrogen peroxide in the presence of aqueous sodium hydroxide. So that's the whole mechanism, the 2-step reaction. Okay, now do this question, Ali. First question and the second one. And please tell me the answer.
Done, ma'am.
Okay, tell me the answer. Final answer.
CH3, CH2, 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 OH.
Okay. Okay, and what about this one?
Methyl cyclopentanol.
Okay, see. So in this case, basically, in the hydroboration oxidation reaction, you have to follow anti-Markovnikov of addition rule. When you don't have to write down the mechanisms, and then how you will write down the product only. So you have to follow anti-Markovnikov of addition rule. Okay, so OH group should be attached to that carbon which has more number of carbon, just opposite of that Markovnikov of addition. Okay, so suppose this is your first and this is the second carbon. Okay, so this is this carbon, the second carbon has how many hydrogen? Two hydrogen, right? And this first carbon has only one hydrogen, only one hydrogen. So that's why you have attached OH group to the second carbon, which has more number of hydrogen. So you are using the anti-Markovnikov rule. Means the OH group, the nucleophile should attach to that carbon which has more number of hydrogen. Okay, so in the second case, क्या आप करोगे? Suppose this is the first and this is the second, right? So on the first carbon, 1, 2, 3, 4, there is zero hydrogen, right? But on the second carbon, there is one hydrogen. So you will attach OH to that carbon which has more number of hydrogen. And in this, the second position, the second carbon has more number of hydrogen. So you will attach OH on the second carbon and CH3 as it is. Is it clear, Ali?
Yes, ma'am.
Yeah. So in the first case, in the first reaction, acid catalyzed reaction, you have to follow the Markovnikov addition rule. And in the second reaction, hydroboration oxidation reaction, you have to follow the anti-Markovnikov addition. Okay. The next reaction, the next method of preparation is from the haloalkane. Okay, haloalkane or alkyl halide. So see, suppose we have RX haloalkane. When you treat it with aqueous sodium hydroxide or potassium hydroxide, okay, aqueous potassium hydroxide or sodium hydroxide, so you will get this haloalkane or haloalkane will get converted into a ROH plus your HX. So what happens? This X will be replaced by OH group plus HX. So you will get alcohol. This is very basic reaction. And can you please tell me which type of reaction it is? This is nucleophilic reaction, right? This is nucleophilic substitution reaction. So what happens? See, this RX, suppose we have CH3Cl. This is CH3Cl. And you are using aqueous potassium hydroxide. So it will dissociate to form K plus and OH minus. So what is nucleophile? Nucleophile is OH minus over here, right? So this nucleophile, because between this carbon and chlorine, the chlorine is electronegative, right? So it will acquire partial negative charge and the CH3 will acquire partial positive charge. So this nucleophile will attack that carbon. So nucleophile comes and attack this carbon and at the same time this chlorine, because it's a good living group, so it just leave the group. Okay, it just leave. So this is basically a bimolecular, this is an SN2 reaction. What is this? This is a bimolecular nucleophilic substitution reaction because reaction occurs in a single step. Nucleophile attacks and the living group left. Okay, so and you will get CH3 OH. Okay, and because you have K plus also, this K plus will potassium will get attached to the chlorine and it will combine with chlorine and it will form KCl. So you will this CH3 alkyl halide, it gets converted into a alcohol plus ACl via nucleophilic substitution reaction SN2 mechanism. Is it clear, Ali?
Ma'am, it will be KCl or HCl?
It will be KCl. Oh, sorry, just a second. This H or HX. Just a second. Let me show you. will be KCl. It's correct. It's KCl. And here you will write K, your NaX or KX. If you are using sodium hydroxide, so it will here KX or NaX you will. Okay, so salt will be you will get the salt. Okay, potassium salt or sodium salt. So it again depends on the sodium hydroxide what you are just taking. Aqueous sodium hydroxide आप लोगे तो it will give you a NaCl, and if you are using the potassium hydroxide, so it will give you a KCl. Okay. Okay, so just correct the general reaction. So it is again, it's a nucleophilic substitution reaction. The mechanism is very simple. Again, the first one-step mechanism will be there. The nucleophile attacks the carbon and the living group just left, and you will get a alcohol plus KCl, the salt. Okay, second question, cyclo. Okay, cyclic structure it is. Okay, so this again potassium hydroxide you are using. So this it has K plus and OH minus. So this OH it gets attached. OH will attack this carbon, right? So between this carbon and this chlorine, chlorine has a partial negative charge and this has partial positive charge. So nucleophile, because it's electron rich, so it will attack this carbon. And so when it attacks, so this chlorine will leave and you will get cyclopentanol. Cyclopentanol. Okay, and in your exam, no need to write down the byproduct, just write down the main product. So this is the method of preparation from haloalkenes. Okay, and mechanism is via nucleophilic substitution reaction, bimolecular nucleophilic substitution reaction. And write on the note, when you are using the tertiary haloalkene, okay, if you are using the tertiary haloalkene, so you know very well, it will give you a mixture of alcohol and alkene. Alcohol and alkene on treatment with aqueous potassium hydroxide or sodium hydroxide. So that's why we don't prefer the tertiary alcohol in the method of preparation. When you are when you have to prepare the alcohol, so you don't prefer the tertiary haloalkene. Okay, either you can take the primary haloalkene or secondary haloalkene. Okay, tertiary haloalkene loge to there will be more hindrance, there will be more alkyl group. So due to that, there will be some nucleophilic reaction to ho gayi. Nucleophilic ke alawa elimination reaction will be there. And if elimination reaction will be there, some eliminate honge kuch groups, so you will get a alkene. Okay, you will get a alkene. So that's why in that when you are just using the tertiary haloalkene, okay, and you are just treating it with aqueous potassium hydroxide, so you will get a mixture of alcohol plus alkene. And for when you get a mixture, so after you are not getting the desired product, you are getting the mixture. So after at last we have to purify. Okay, after that you have to purify. Further purification ki need hoti hai. So that's why we are not preferring this tertiary haloalkene in the method of preparation of tertiary alcohols. Clear, Ali?
Yes, ma'am.
Okay, so first let's write down. Have you written all the notes?
Oh, ma'am.
Okay, just quickly write it down.
Done, ma'am.
Okay.
Done, ma'am.
These questions we have already done. Now this one.
Done, ma'am. Done, ma'am.
Okay. Okay, now the next is here from carbonyl compounds. Okay, you know very well what is carbonyl compounds? So aldehydes and ketones in which CO group is present. So that is your carbonyl compounds. So from carbonyl compounds, we can also prepare the aldehydes. Okay, by the reduction of your carbonyl compounds, we can prepare aldehyde. So first write down from carbonyl compounds and the A is reduction of aldehydes and ketones. Okay, so suppose we just take the CO group. You know, in both the aldehydes and ketones, CO group is common. So if you take this carbonyl compound and if you are just adding the reducing agent, any reducing agent, so what happens? You know, what is reduction? Reduction is the addition of hydrogen. What is reduction? Reduction is the removal of oxygen or the addition of hydrogen. So here what happens? Two hydrogen, one hydrogen get attached to this carbon and one hydrogen get attached to this oxygen, right? And you have to break this. The old bond, this carbon and oxygen, double bond will be break. Okay, and new bond will be formed between carbon and hydrogen and the oxygen and the hydrogen, right? So what you will get this carbon and one bond, which is CH, CH, and here, what this bond will be break and you will get OH. So this you will get alcohol. On the reduction of carbonyl compound, you will get alcohol. Okay, so what you're supposed to do? Just two hydrogen, you have to attach one hydrogen to the carbon, okay, and one hydrogen to the oxygen, and just break this carbon and oxygen pi bond. Okay, so you will the aldehyde or ketones, okay, will get reduced to the alcohol. Now let's see some reducing agent. Okay, so aldehydes and ketones can be easily converted to alcohol using suitable reducing agent, such as first reducing agent when you do the catalytic hydrogenation. Hydrogenation means the addition of hydrogen H2 in the presence of a catalyst, right? So which type of catalyst? Like nickel, palladium, platinum. So these catalysts, right? So H2 in the presence of nickel, palladium, platinum. Okay, this catalyst is known as catalytic hydrogenation. So you can use this H2 आप use कर सकते हो in the presence of any catalyst, nickel, palladium, platinum to reduced. Okay, for the reducing agent. So this is a reducing agent. Second is you can treat the aldehyde or ketone with a lithium aluminium hydride. Okay, so lithium aluminium hydride LaH. Short में हम क्या कहते हैं? LaH. Lithium aluminium hydride. So this is the strongest reducing agent. So this lithium aluminium hydride is the strongest reducing agent. It can reduce any group, okay, any of the group, whether it's a ester, aldehyde, ketone, okay, any group को वो reduce कर देता है. So that is your lithium aluminium hydride, strongest reducing agent. Now come to the third one, sodium borohydride, NaBH4. What is this? This is the sodium borohydride. Borohydride. Okay, so the sodium boron hydride is a reducing agent, but not as strong as compared to the lithium aluminium hydride. So lithium aluminium hydride has the ability to reduce any group, but this sodium borohydride can only reduce the carbonyl compound. Okay, aldehydes and ketones. Just remember the difference. If you are using the lithium aluminium hydride, so it can reduce any of the group. Okay, and the sodium borohydride has a limitations. Okay, it can be used in a limits. Just it will reduce only a carbonyl compound, whether it's a aldehyde or ketone only. It will not be able to reduce the ester, carboxylic acid, etc. Right? So this is not as strong as the lithium aluminium hydride. Fourth one, sodium in the presence of a ethanol. Okay, sodium in the presence of a ethanol. You can also use as a reducing agent. Now the question is why lithium aluminium hydride is strong as compared to the sodium borohydride. Okay, so what happens? This lithium aluminium hydride, so the bond lithium aluminium hydride and the sodium borohydride. Okay, NaBH4 and LiLH4. Li, lithium and aluminium and hydride. LiLH4. So why the lithium aluminum hydride is more stronger as compared to the sodium borohydride? Okay, so what happens in aluminium is, you can see here the aluminium is present in the lithium aluminum hydride, and in the boron, it's sodium borohydride, boron is present, right? And aluminium is less electronegative than boron. Aluminium is less electronegative than boron. So the bond, the aluminium and hydrogen bond in lithium aluminum hydride is more polar. What happens, this aluminium and hydrogen bond जो होता है, this is more polar. Okay, and due to the more polar in nature, they are more strong reducing agent. They can reduce any of the compound. Okay, they can reduce, they have the ability due to the aluminium and hydrogen bond. Okay, due to the more polarity of the aluminium and hydrogen bond. Okay, because it is less polar. Okay, this is less electronegative, right, than the boron. Between the boron and hydrogen bond, if you compare boron and hydrogen bond to the aluminum and hydrogen bond, so this aluminum and hydrogen bond is more polar as compared to this boron and hydrogen bond. So that's why, due to the more polarity, this lithium aluminum hydride is strongest reducing agent, strong reducing agent, okay, as compared to the sodium borohydride. Clear, Ali?
Yes, ma'am.
Okay, so these are some reducing agents which we are going to use in the reaction. H2, okay, in the catalytic hydrogenation, we will use the H2 in the presence of any catalyst, nickel, palladium, or platinum. Second is the strongest reducing agent, lithium aluminum hydride. Sodium borohydride, just uh, you should be careful when you are using the sodium borohydride. It will only reduce carbonyl compounds, okay, ketone or aldehyde. And you can also use sodium in presence of ethanol. Sodium in the presence of ethanol. Okay, now let's see. Let's see different reactions. So first, suppose we just take the aldehyde. Suppose we just take the aldehyde. Suppose this is R, CO, and this is H group. So what is this? This is the aldehyde group. So on aldehyde group, on the reduction, on treatment with the reducing agent, it will get reduced to the primary alcohol R. What happens? I just tell you the trick. What you're supposed to do? One hydrogen to the carbon and one hydrogen to the oxygen. Okay, what is reduction? Reduction is the addition of hydrogen. So you have to attach two hydrogen, one hydrogen to the carbon and one hydrogen to the oxygen. So you will get R to this carbon. How many hydrogen? Two hydrogen, RCH2, and you are supposed to break this bond. Okay, pi bond आपने break करना है, and you will get OH. RCH2OH. So on the reduction of your aldehyde, you will get primary alcohol. Okay, so it's very simple. Reduction of aldehyde will give you a primary alcohol. Now see, when you reduce the ketone, suppose this is R, CO, and R dash. Okay, if I remove H from here, the hydrogen will be replaced by any alkyl group, other alkyl group R dash. So this is ketone, right? What is this? This is a ketone. And when you are using the any reducing agent, okay, on the treatment of reducing agent, what happens? This ketone, again the same thing you have to do. One hydrogen to the carbon, one hydrogen to the oxygen, and just break this bond. So what you will get? R, C, and now only one hydrogen is there. One hydrogen is there, and there is R dash. Okay, R dash, and this bond will break, and you will get OH. And you can also write it. आप ऐसे लिख लो इसे R. This is CH, and this is R dash, and on the second carbon there is a OH. So this is your, what is this? This is a secondary alcohol. So on the reduction of ketone, you will get a secondary alcohol, but on reduction of aldehyde, you will get a primary one. Is it clear?
Yes, ma'am.
Okay. So aldehyde will give you primary alcohol on the reduction. Ketone gives secondary alcohol on reduction, and the number of carbon atom should be same. Okay, you don't have to alter the number of carbon. The number of carbon will remain same. Okay. Yeah. This thing you can note down. Lithium aluminum, why lithium aluminum hydride is more stronger as compared to the sodium borohydride. So due to the aluminium and hydrogen bond, because aluminium is less electronegative than boron. So the aluminium and hydrogen bond in lithium aluminum hydride is more polar. So therefore thereby making LH a strong reducing agent. Second point is lithium aluminum hydride will reduce every group. Okay, everyone, no, don't write everyone, every group. But sodium borohydride will reduce only RCHO aldehyde and your ketone, means carbonyl compounds. Okay. Third point is sodium borohydride, NaBH4, and your catalytic hydrogenation, H2 in the presence of a catalyst, do not convert carboxylic acid to alcohol, right? Because in carboxylic acid, two oxygen are there, right? And what is reduction? Reduce कर रहे हो आप, reduction करा रहे हो means you remove कराना है आपने. Oxygen, either you have to remove the oxygen, okay, or the addition of hydrogen is the reduction, right? So there are two oxygen, and it is very so to remove the two oxygen, you need a strongest reducing agent. Okay, so sodium borohydride and the catalytic hydrogenation will not convert this carboxylic acid to a alcohol. Just keep this in your mind. This is important. Okay, so when you are using, if they just give you the carboxylic acid group, and on the arrow, above the arrow, they will write on the H2 in the presence of a catalyst. So it will not convert the carboxylic acid into a corresponding alcohol. Just remember. Okay, you need a stronger reducing agent like your lithium aluminum hydride to reduce carboxylic acid to a alcohol, corresponding alcohol. Yes, Ali?
Yes, ma'am.
Okay, so quickly write down this point, then we will do some questions.
Ma'am.
Yes, done? Okay. Okay, just quickly do this question. Let's see you got the point or not. CH3, write down the major product. Okay, let's do some question. Then the remaining questions will be CH3, CH2, CHO, right? So this is your aldehyde. So, and you're using the H2 in the presence of a catalyst, H2 and nickel catalyst. So this aldehyde group will be converted to a alcohol. Okay, this will get reduced to a alcohol CH3, CH2, and CH3, CH2. Okay, the number of carbon should be same. Just remember. Now, number of carbon should be same, and उसी number of carbon से आपने क्या बनाना है? Alcohol. So it will be CH3, CH2, and CH2OH. CH2OH. Okay, the addition of two hydrogen will be there. So it will give you a propanol. So the propanol will get converted to a propanol in the presence of a H2 nickel catalyst. What about the second one? You are using the lithium aluminum hydride. So it will again, it will reduce, it's a strongest reducing agent. So it will reduce any of the group. So it's a CHO. So CHO will get converted into a corresponding alcohol. So just CH3, CH, CH3. And what about this CHO? So CHO will get converted into a C. The number of carbon should be same. So it will get converted into a CH2 and OH. Here, Ali, this one.
Yes, ma'am.
Okay, what about the third one? This is a ketone group. So ketone will get converted into a, okay, just think about it and do the remaining one. Let me know. From question number 3 to question number 9. Okay, good. Done, Andy?
Yes, ma'am, done.
Okay, what about the third one?
CH3CH OH CH3.
Okay, good. This one, fourth question.
CH3CH OH CH2CH3.
Fifth one.
Cyclopentanol.
Fifth one is cyclopentanol. Sixth one is the
No, ma'am, sorry.
cyclopentanol, no?
Fifth one is CH3CH2CH2CH2OH.
Okay, good. This one is a cyclopentanol. Okay, so in place of CHO group, so you have to place this lithium aluminum hydride will reduce the CHO group to CH2OH. CH2OH group. Okay. And yeah, what about this one? Lithium aluminum hydride will reduce. There are two groups, CHO and oxygen here. Okay, so it will reduce both the groups to a corresponding alcohol. So you will get here, you will get OH instead of oxygen, instead of ketonic group. And in the place of carbon, CHO, okay, you will write CH2OH. That will be your. And you can also write like this. 1, 2, 1, 2, 3, 4, 5, 5 carbon, 1, 2, 3, 4, 5 carbon, and 1, 2, 3 on the third carbon, fourth and fifth carbon. But first, second, third carbon, OH group is attached on here, the last terminal carbon. Now this one. Okay, so oxygen,
OH
yes, in
OH in
place of
place of
this,
ketone and
yes,
CH2OH.
it's good. Okay, just a second. Let me do one question. Okay, let's do some question. Then I will do the question. Okay, so B part is the reaction with Grignard reagent. The reaction of carbonyl compounds with the Grignard reagent. What is Grignard reagent? RMgX. Okay, RMgX के साथ क्या reaction होगा हमारे carbonyl compounds का? Let's see. Carbonyl compound is your this ketonic CO group. Okay, if I attach H over here, R over here, so it will become aldehyde. And if I attach R and R dash over here, so it will become ketone. So in both the carbonyl compounds, aldehyde and ketone, CO group is common, right? So when you treat it with RMgX, okay, RMgX. So you know very well when the magnesium is attached to the alkyl group. So magnesium is electropositive, so it will acquire partial positive charge. And this alkyl group in this is will acquire partial negative charge. Okay, and what about this one? Between carbon and oxygen? Yes, Sahil, which one is more electronegative? Between
Uh,
carbon and oxygen, which one is more electronegative?
Oxygen.
Yes, so oxygen will acquire negative charge and this will acquire partial positive charge. So this alkyl group, okay, so this alkyl group will get attached to this carbon and this bond will shift over here. Okay, so what happens? So this carbon in this alkyl group you will write down over here and this oxygen, on oxygen पे क्या आ जाएगा? Minus charge. So if it get minus charge, so this MgX will attached over here, MgX, right? Now, further hydrolysis. This is again a two-step mechanism. First step में you have to treat the carbonyl compounds with a Grignard reagent, and on further second step में क्या होगा? Just hydrolysis. On the further hydrolysis, what happens? H2O. Okay, so again you know very well it has H plus and OH minus. Okay, so this minus part, this is oxygen as a negative charge, and this whole thing, MgX, will have positive charge, right? So the hydrogen will get attached to the oxygen part, the negative part, and this MgOH X will get, you will get C Okay, and here OH plus you will get MgOH(X). This is your byproduct. So that's how you will convert the carbonyl compounds into a corresponding alcohol. Okay, so when you are using, so you will get, suppose you will, if you attach hydrogen over here, so we will get it after some time. Like when you do, three reactions will be there, formaldehyde, other aldehyde, and ketone. So in all the cases, we will get the different alcohol. Primary alcohol we will get in the formaldehyde. When you treat the formaldehyde with the Grignard reagent, you will get a primary alcohol. And other than the primary alcohol, other than the formaldehyde, if you are using the aldehyde, which is not a formaldehyde, other than formaldehyde. So if you are treating the other aldehyde with your Grignard reagent, so you will get a secondary alcohol. Okay. And third one is when you are using the ketone. Okay. Ketone is treated with a Grignard reagent, you will get a tertiary alcohol. Okay. We will see that each and every cases with example. But first, let's write down this. Write down the whole mechanism, the reaction with Grignard reagent. Okay. And after that, you can write down this reaction. Whole reaction. First, this is again a two-step mechanism. First step is the reaction with the Grignard reagent, and the second step is the hydration. Okay, again you have, just keep this in your mind, carbon double bond oxygen. Okay, this pi bond will break, okay, and the new bond will be formed between the carbon and R alkyl group. Cr bond will be formed and the OH bond will be formed. These two bond will be formed and this carbon and oxygen double bond, pi bond will be break in this case. Clear, Ali?
Yes, ma'am.
Okay, quickly write down. Written, Ali?
Yes, ma'am. Done.
Okay. Now let's see one by one what will be the reaction of Grignard reagent with formaldehyde, your other aldehyde, and the ketone. So suppose if you take the formaldehyde, okay, so you know very well what is formaldehyde, Ali? What is the formula of formaldehyde?
CH2O.
Yes, H2O. So basically HCHO. So this is your formaldehyde. When you treat it with, again, the same mechanism you will follow. In the first step, you will treat it with RMGX, Grignard reagent, followed by a hydrolysis. Okay, so again, the mechanism will be same. So you have to break this carbon and oxygen bond, pi bond you have to break, and new bond will be formed between Cr. So step by step, let's see. First step, what happens? This has a negative charge and this will have the partial positive charge. And between this carbon and oxygen, this will have the partial positive charge. So this R group will attach over here, okay, and this bond will shift away. So H, C, R, okay, and hydrogen over here, and this oxygen minus charge, and this whole thing MgX will get attached to oxygen, okay. Now, further hydrolysis, H2O. So H2O will give you H plus and OH minus sign, right? So this H plus will get attached to this oxygen, okay, and this Mg will get attached to this. So you will get H, C, R, and here OH, and again A, H plus here you will get Mg, OH, X. So this will be your final product. And you can also write it like RCH2OH. So what is this? This is your primary alcohol. What is this? When you rearrange this, so you will get RCH2OH. So this is your primary alcohol. So this is example when the formaldehyde is treated with the Grignard reagent, okay, followed by the hydrolysis. So you will get a primary alcohol. Clear, Ali?
Yes, ma'am.
Similarly, in the second case, when you take the other aldehyde other than the formaldehyde, so RCHO group, and when you treat it with, I'm not writing the whole mechanism, you know the mechanism. Mechanism is very simple. Just treat it with the Grignard reagent followed by the hydrolysis. So I'm just writing the reagent. First step RMGX followed by the hydrolysis. Okay, suppose so here R group was again there, okay, already there. So I'm writing R dash. Okay, so avoid the confusion. So it will be R, C, H, R dash, and you will get OH. Okay, you will get OH over here. So basically, when you treat the other aldehyde on the treatment with the Grignard reagent, so you will get secondary alcohol. What is this? This secondary alcohol. OH group is attached to this carbon, and this carbon is further attached to two groups. So it is your secondary alcohol. Clear, Ali?
Yes, ma'am.
Similarly, third case में when you treat the ketone, suppose we just take the ketone R, C, R dash, and this is a ketone, and on treatment with the Grignard reagent RMG, suppose this is R and R dash. So I'm just writing the R2. Okay, suppose this is the R1, okay, R1, and I'm just writing the R2. In the second case, second followed by the hydrolysis. So R carbon, this bond will break, a new bond will be formed between this car and the Grignard reagent follow this alkyl group R2. So you will write R1, here R2, and this OH. Okay, here you will get OH. So you can see this OH is attached to this carbon, and this carbon is further attached to three groups. So you are just getting the tertiary alcohol. So in different cases, you are just getting different alcohols. So first case, when you're just treating it with the formaldehyde, you are getting the primary alcohol. When you are just treating the other aldehyde with the Grignard reagent, so you are getting the secondary, and ketone आप use कर रहे हो, so you are getting the tertiary. Is it clear, Ali?
Yes, ma'am.
Okay, so let's do some questions. Write the products for the following. Write the products for the following. So it's simple. You can see over here. Same mechanism you will follow. So this is formaldehyde, SCHO. SCHO को किससे आप कर रहे हो? RMGX. So instead of R, what is this? This is a methyl group, CH3. Okay, so let's do the mechanism. First step. So you know very well this is yeah. So basically, what will be the product in this case? So product will be your C, this C group, CH3, and this one, this CH2, OH. This will be your product. Now let's understand the mechanism of this reaction. I'm writing the mechanism here. Suppose this is a H, CO, and H. H2, CO. This is a formaldehyde, and you are just treating, first step you are just treating it with CH3, MgBr. Okay, you know very well this magnesium will acquire partial positive charge and this will get partial negative charge. Between this carbon and oxygen, this carbon have the partial positive charge. So this methyl group will attach this carbon, okay, and this bond will shift over here. So you will get C H and the CH3 will get attached over here and oxygen which has a negative charge. So negative charge से क्या attach हो जाएगा? Whole thing MgBr, MgBr which is positively charged. Right. Now next step में second step will be the H2 addition of H2. So H2 has H plus and OH minus ion. So H plus get attached to the O oxygen which will give you HCH, CH3 over here, and here OH, plus MgOHBr. That will be your product. And you write down this one. इसे क्या लिखोगे आप? CH3, CH2, OH. So you are just getting the primary alcohol. So it's very clear. You can see this is formaldehyde, and formaldehyde, when treatment with the Grignard reagent, you will get a primary alcohol. Clear, Ali?
Yes, ma'am.
Okay, so if you understand the mechanism, so it is very simple to write down the reaction. Okay, and so suppose in this case also, second case maybe you will get the primary alcohol, third case maybe you will get the primary alcohol. Okay, so this is your homework basically. Second, third, fourth, fifth. Okay, just write down your homework. Fourth one is your other aldehyde, other than the formaldehyde. So you will get the secondary alcohol. Fifth one is your ketone. So in the case of ketone, you will get the tertiary alcohol. The reaction mechanism will be very simple, very easy. You have to follow the same mechanism, same step, and you will get the right product. Okay, quickly write on the homework. These are your homework. From question
Ma'am,
number 6. Yes, Ali?
ma'am, in the third one, it is MgCl.
Yes, it's MgCl. This is structure. Here, MgCl.
Okay, ma'am.
So these 4 questions is your homework. Written, Ali?
Yes, ma'am, done.
Okay. Okay, so we will continue this class tomorrow from carboxylic acid. So we will practice more questions. If there is any doubt, you can ask. Everything is clear?
Yes, ma'am.
Okay. Okay, so thank you.